I think now we are going to have a session where we talk through the process of design from an architect's and an engineer's point of view. And I'm delighted to now fly over to Plymouth, where Matthew is going to talk us through his experience from a designer's point of view. Over to you, Matthew.
Great. Thanks very much, Tom. Hi again, everyone. So talking from the comfort of the Plymouth prototype, the first meeting we've ever had in this building. So it's kind of nice to be able to use it finally. So yeah, talking about it from the designer's perspective, when we were talking this morning about different materials and material science and all of the laboratory experimentation that went on to kind of prove the concept of the CobBauge walling system. It takes quite a leap of faith to get from the construction material to a real life building. And in order to do that, you know, you've got to take the material and you've got to understand how you can construct using it. You've got to understand the details. So what we ended up doing was working as part of a technical team. So it's a rich group of professionals on board. Anthony Hudson from Hudson Architects and his team were pivotal to this. We have Barry Honeysett also on the line, and his information and knowledge of traditional COB for structural engineering was really important. And we use those sessions to work together to develop standard technical details for a typical CobBauge building. We were then able to start putting into practice some of those construction details. So the first building, which you just saw, was by Francois and Raphael. So they were able to start testing some of those details. As they were progressing through their building, us as the Plymouth crew and me as the project architect for the Plymouth building, were able to learn a lot of lessons that had been made, or a lot of lessons that have been learned from the French prototype. So some of the things that perhaps didn't go quite as well, we could try and address those on the Plymouth prototype. And now Anthony and Hudson Architects are working on the Norfolk prototype, and they're also able, they have the added benefit of learning from some of the mistakes that we made also on the Plymouth building. So little by little, we're edging towards a deeper understanding of how you detail a CobBauge building. Now, when we set out starting the detailing process and the design process, you learn quite a lot from history, and you can learn a lot from traditional COB buildings. Also learn quite a lot from other earth and construction, such as light earth construction, and how you detail in and around windows on the outside, just trying to minimize water ingress around some quite sensitive openings, which you'll find with the light earth construction. So we spent a lot of time trying to work through some of those tricky details, and I'd like to say, fortunately, we haven't had any major problems with the Plymouth building. Just a few sort of niggles here and there, which we were able to iron out. Now, I've got a couple of top tips, which I've got in a video, and I'm just going to try and share my screen, see how well this works. So I'm going to go to the training videos. This is the website for the training videos. And then down towards the bottom, we've got a video which shows what a designer needs to know. So I'm going to click on one of those, and it takes you to a YouTube site. I'm going to share this video.
Welcome to this brief summary of what a designer needs to know when planning out a CobBauge building. My name is Matthew Fox from Fox Ecological Architects, designer of the UK's first CobBauge building down at the University of Plymouth. This happened to be my first earth building project, which started with a steep learning curve. However, now this building's been completed, I can share some of the lessons learned. So here are my top 10 tips to designing a CobBauge building. Top tip number 1. CobBauge is unlike most other building materials that you'll be used to. So take some time to familiarise yourself with the CobBauge material and construction methodology. There's really no reason to limit your creativity when designing with CobBauge. Whilst there will be some challenges compared with traditional materials, there will also be opportunities to try something new and unique. On the Plymouth building, we explored the use of curved formwork, which proved highly successful at demonstrating alternative design forms to square edges. 2. Build a team that are open to earth building techniques. On the Plymouth prototype, we worked closely with the client and design team consultants to explain what the CobBauge material was and how this material would impact on design decisions. Number 3. Be sure to source your earthen material before tendering for a contractor. To enable the project to hit the ground running, make sure you invest time and effort early on in the design phase to locate the correct earth and fibre materials. This will involve various forms of soil investigation and testing to make sure you have the right earth for the job. Time spent early on to find the right soil and to optimise the best mixtures for both the structural and thermal mixes will make site mixing much quicker. In addition, it's important to calculate the volume of soil required to make sure your contractor has sufficient material. Tip number 4. Pay attention to the details. As with traditional CobBauge requires a good hat and a solid pair of boots. The hat is the eaves and provides good protection from the rain. The boots are the plinth, which need to be around 400 mm high from the external ground level to prevent splashback and rising damp. Other details, such as window openings and service penetrations, should also be considered as part of the technical design stage. For guidance on detailing a CobBauge building, please refer to the standard details which illustrate key junctions and fixings for a CobBauge building. Top tip number 5. Plan out your build program early on. There are 2 critical aspects that will impact on the program for a CobBauge building. The first one is that your clay-rich subsoil will be wet when laid. At approximately 600 mm thick, the wall will therefore take a long time to dry. And while drying, the earthen material will shrink. So you need to allow adequate time for drying and shrinkage, since this drying time will directly impact on the fitting of windows, doors, and finishing the walls. The second item to be aware of is the time required to move the formwork. This is almost as long as laying a single lift of cob. Therefore, you should leave sufficient time in the program to reposition the formwork. On the Plymouth building, we had 2 full lifts of formwork. The height of the formwork matched the height of one lift. We left the formwork in place for 3 weeks before moving the formwork up on top of the second lift. We found this to be sufficient time for the earth to set firm enough to support the weight of the new lifts above. With 2 or 3 complete sets of formwork, you can leapfrog the formwork as you rise. 6. Work closely with the contractor. When appointing a contractor, be sure to talk through the CobBauge process in advance and in detail. Make sure that they are confident with the material and the methodology, especially the mixing of the material and using the formwork. You should direct contractors to the CobBauge Guide for Builders, which outlines the CobBauge methodology. Tip 7. Keep the walls dry during construction. No one can predict the weather in the UK, and even in the summer, we can have torrential rainstorms. It is, however, important to keep the stored cob material and walls protected from precipitation. For the stored material, if this is exposed to the rain, the mix ratio will likely change and become too wet. If this material is too wet, then it will take much longer to dry and cause problems later on. For the walls, rain on the wall face is not a problem. Ponding on the tops of the unfinished walls, however, can pose problems with water soaking into the material. To overcome these issues, it's important to take protective measures to minimize the risks from overwetting. Number 8. Test the materials at regular intervals. To ensure consistency in quality between mixes and lifts, it's advisable to conduct some of the simpler site tests, such as the puddle test or the drop ball test at regular intervals. Encourage your contractor to get into the habit of testing materials. These simple tests will indicate whether the mixture is too wet or too dry before adding this to the walls. 9. Consider natural finishes for the walls. CobBauge is a breathable construction. Furthermore, it can take a year or more to fully dry out after completion. It is therefore essential to use internal and external finishes that work in harmony with the overall breathability of the wall construction. On the Plymouth building, we used an external lime render and internal clay plaster finish. Whilst there are other natural materials for finishing the walls, You need to make sure that you take time to talk with the client through the benefits and maintenance requirements of natural finishes early on in the design stage. And finally, tip 10, build a sample before you start. Work with your contractor to build a small 1:1 scale sample section of walling before they start building the main wall construction. Use this as a learning exercise and to confirm the method of mixing the material that has been proposed for the main building. In addition, undertake sample finishes on either the finished building or on small-scale samples. This will help to decide upon the best solution for finishing the building. In conclusion, CobBauge is a rewarding material to work with. As with all projects, the time spent at the start planning and preparing for the build will pay off when you get on site. I'm glad that you're interested in using this material, and I wish you every success with your future CobBauge construction. Thank you for watching.
Thank you, Matt. That was fantastic. That was an overview of Matthew's experience in Plymouth, which was the first UK building. And now I'd like to introduce you to Anthony Hudson, who's been leading the design of the building, a commercial development in Norfolk, which is currently on site and displays other aspects of the design process.
So you've seen a lot about lots of videos of the of doing CobBauge. So our role in the whole project. Can you see that? Can you see the shared?
Yes. Yeah.
Oh, great. Our role in the process was to form a kind of design guide for designers, and it's all again on the website, which is fantastic. And our guide designers basically kind of has basically pulled everything together as a sort of summary of all the things you should consider as you build a CobBauge building. Now, this design guide it's 37 pages. You can see it's going to probably increase over the next few months again as we kind of add more and more stuff. But most of the stuff is in here, and the contents are kind of goes through the raw materials. And I'll quickly run through this. I won't go through the detail because it's too much detail, but it just gives you a sense of what we've got. It's an introduction. We've talked a lot about CobBauge up to now. Then it goes through the raw materials, and a lot of the photographs in this guide are from our build in Fakenham in Norfolk, which we'll have a look at later this afternoon. This is the kind of the structural cob which came out of the ground from a place not very far from the site, which is great, and we had to add a little bit of aggregate to it to get to the right particle size. This is the thermal. We talked about the thermal clay, this is 65% clay, and this part of the talks about the needs and the requirements for that, the thermal lightweight mix. We also talk about internal plaster and paint, and you have had some really interesting kind of conversations or comments made by Francois and Matthew on this. Lots of opportunities, and Jim has shown you how these all perform, and this will be also recorded and in this little pamphlet here. We then talk about the mixing ratios of CobBauge, and how you get the right consistencies and the ways you mix it off-site or on-site, depending on your site size and things like that. Again, here's a skip, for example, and this is a system we've been used in Fakenham in Norfolk. And then we've been talking about how you mix the light earth slip here. You've seen the slip puddle tests and things like that, and this is actually making it in a much bigger vat, a hole dug into the ground on site in Fakenham, and mixing the slip and doing some puddle tests as well. And then also that was sieving the slip. And then here are various different ways of mixing the slip and the hemp shiv to create the lightweight thermal mix. And then some guidelines on volumes and calculations that you'll need to be making to get those right consistencies, and also with the light earth. This is just showing the kind of testing. This is the laboratory testing, we've had sort of laboratory testing and also touch and sensing with your hands. So you've got, as Becky's been talked about, is getting the sense of what the material's like, but also having to go to the laboratories to actually kind of to test these things. And then particle size, this is a grading particle size, and between these two green lines you can see what's acceptable for the kind of, this is the structural CobBauge, and the material that we found locally was this dark black line here, and that was just slightly outside that green region, so we've had to add a little bit of ballast to bring it into this green region. This line is the line for the very clay-rich soil that we found north of the site, and this is a 65% clay, and that's actually perfect for the light earth. So that's been really, really great. So then we move on to testing, and we've for example, for that light earth clay, we wanted to see whether it was still coming up to the same thermal performance that the Plymouth build had. And to our excitement, we were actually doing very, very much better. It's a very much stronger clay, and it produced better thermal performance than we anticipated. And then there's on-site testing. Becky has shown you some really lovely videos of all this, and also Kevin of throwing, of puddle tests and ball tests and splat tests. And then we go on to the ground investigations and how to best kind of support the CobBauge wall. We've talked a little bit about formwork. There are lots of ways of doing the formwork, and we'll see another way of doing the formwork in our project at Fakenham. And Francois and Roland have talked about, this is, you can see the metal formwork which was used in France, and the timber formwork which was used in Plymouth. And we inherited that timber formwork because we want to recycle it, and we've adapted it on our project as well. And then we've shown you the sort of diagrams of the different ways of putting the formwork together, and you can see that zigzag kind of zigzag arrangement between the light earth and the CobBauge. And then we've got our guidelines for the placement tools and dimensions for them. This is for a lot of chat has been on why are those angles there, and that lower area is 200 high. You can see the lower which counts in 200 high, which is the lift, each lift that we do, and then the count back in again allows you to get the cob in an easy way, and the structural cob in an easy way. And there's some further diagrams of that and the profiles that result from that using that thing. And more about kind of laying the lifts, which you have heard quite a lot about, and then tamping the lightweight cob in after you put that first lift of structural cob, and then laying this hemp reinforcement across the tops of each lift to just make sure everything ties together beautifully. Then just some little guidelines about, which we also mentioned, checking the compaction of the cob in the formwork, then repositioning the formwork as you go up in lifts. Again, this is more akin to what Matt and co did at Plymouth, and as we've done a slightly different one. We'll be showing different alternatives later. And then the drying time between the lifts, and the importance of monitoring that moisture content with these RAM-in sensors, which Jim has designed and have been really, really useful in understanding how the cob dries out. We've got a section which we haven't completed fully yet, which is on door openings, window openings, and larger openings, but we can look at a little bit more detail on that when we go to the details. And then we've got a section on all the sort of issues that you might encounter on site. For example, if things are drying out too quickly and you get cracks, how you might mend those cracks, and how you might kind of come, sort things out that which you didn't quite expect. Then we do a little bit about the scaffolding and where the scaffolding should go. On most of the sites, the Plymouth site and the Fakenham site, we have the scaffolding on the outside of the building. Lots of discussions we had yesterday at our open day about perhaps putting it on inside, but these are all developing ideas as we get to do more and more building with the CobBauge system. And then we're moving CobBauge around the site and how that works. So that is kind of a brief run through of the of our method, our guide to designers. I would like then now to move on to the details, and again, it's in this document here, technical documentation, and so we then go to design details. And these are a set of generic details. Some of them are kind of for which were developed in France. Some of them were developed in England, and then we now pull these all together. And we're basically going to go through relatively quickly. Again, they're all on this website, and they'll be sort of added to as well. But we've got foundations, we're looking at windows, we're looking at intermediate floors, and then we're looking at eaves details. Now, here's a detail that this is very close to the detail that we're doing in Fakenham in Norfolk. It's a suspended floor, but the most important things you'll see here are the 500 millimeter plinth. We could make that lower, but I think it's probably advisable that it's this height, just to stop the splash back, and we really don't want to get moisture into the lower bits of the cob here. You'll notice there's a damp-proof course down here. We don't want the damp-proof course up here because that'll trap moisture. We want the moisture to be able to come through the cob. The most important bit of the cob to support is the structural cob, which is this width here. And let's go to the structural cob, and this is the lightweight, light earth cob here. So this is where we need the support, and this is where the loadings come. And then we have a thermal break between the side finish facing with and that could be stone. In this case, it's brick here. And then we have our suspended floor, which runs into the plinth here. There have been lots of various kind of variations on this plinth. This is very much the plinth that Matt has used on the cob building at Plymouth, which is a ground bearing slab. This is foam glass here, foam glass infill here. We can vary, obviously with these details, there are some details which are trying to reduce the embodied energy of all the construction as much as possible. And then there are others where maybe the costs are too great for one system like foam glass, and you have to use another way of building. This is a sort of based on a passive house detail, sort of concrete slab, which is all encased in PIR. Obviously, incredibly embodied energy there, but we just thought would like to show the variety of ways you can go about this. And then here we've got a rubble foundation. This is which we wanted to use actually on our project, but when we was costed up, and we got it through building regulations, but when it was costed up by the builder, it was discovered to be too expensive, and then we reverted to a concrete foundation. Window details. You've seen Raphael has just and Matt have gone through, and you've seen those views from the outside. Here's now a kind of cutaway of how it all works, or how some of them work. And again, this is a combination of Plymouth, Fakenham and French detailing. The crucial thing here, I'm going to move to, this is a window on the outside. We've got windows at different places in the construction. This is probably the most likely one, a window set back from the face of the CobBauge by about 150 mil, but it's in line with the lightweight, so that you don't get too much of a thermal break. Crucial things to notice here is this: the lintel is a plywood base with 3 150 by 50 kind of upstands here, all embedded in the cob, and that is set in the formwork as you build up. So that's just then you backfill that with the CobBauge system. Another thing to note is this: we've got this 45 mil gap here, which allows the window to move when the lower bit starts shrinking. It allows movement so that window can then push up and fill that gap there. It again is about, as Matt said, it's about program. If you want to keep moving, you need to keep this. You need to allow for this shrinkage. However, if you wanted to leave it over a year, obviously the shrinkage would have gone, and then you might dispense with that kind of that detail. Crucial also is the sill and the way it meets the jambs of the window, and we've got a little upstand there to stop any damp or any water falling down the jambs there. We then move to the jam detail. So these are all, you can have a good look at these. This is starting to go towards some of the things that Raphael was talking about in his French building, moving the window to the inside. But then you've immediately got problems of your thermal breaks. So we have to have a more thermal wood fiber additional to the soffits of the wall there. Again, jam detail, and then more positions, and we've got door, inward opening, windows, etc. You can go through these at your leisure. I'm going to quickly run through this, and then there's that very deep one here. It's slightly different from what Raphael showed, but it shows you the window totally on the inside. And the jam, the way that they've fixed, they've got built-in timber in the CobBauge wall to fix the jam too. And roof details, pretty simple really. Obviously keeping all the strength, all the support on the structural cob, the wall plate then kind of fixed with heavy bolts down into the cob there. Continuing your insulation of the lightweight earth up here against the end plate to a posi joist or a joist there, and then meeting the fully insulated roof as there, and then obviously pitched roofs, and we've got a flat roof eaves and gutters and green roofs, and then we've got something like this is similar in Fakenham, a kind of good overhang there, parapets, depending on what the condition is and how you want it to work. Again, another eaves detail there. This is the 500. This is actually the detail we have on our Fakenham project, 500 overlap. And this is something similar to the Plymouth prototype with the overhang eaves like that. We talked, again, Raphael talked about, this is a sort of intermediate floor bearing, building in timber into the structural cob, various ways of doing that. So I'll quickly go through those, and building in there, and then cutting in joists, which was, I think, that one there. And then finally, the issue of, if you've got all your CobBauge bearing walls and you're wanting to fit out without letting everything kind of shrink, you've got to allow for any walls that come up against it, and also the roof, any wall support coming underneath the ceiling, to be able to move, to allow for the shrinkage of that CobBauge, because obviously intermediate walls, if they're made out of either timber or blockwork or something like that, or a cob block, which is which has already been dried and will have already shrunk, you now need to allow for that vertical and horizontal movement. And so there's a series of details which allow for that. And they've got these sliding details, and we have a sliding detail similar on top of underneath the ceiling. So that takes us through all the details, and it has to be a bit of a rush, but I hope that helps. And then finally, we have, just for our UK contingent, we have done an NBS specification, which is a which would go with all your NBS, any other NBS clauses, and this is a which would go for that suite of NBS clauses, and we've covered both two things: the walling system and the formwork. So I won't go through the detail of that, but that's also on the website. So I think that is roughly covers everything where we are. And so I'll hand over now. I think I'm going to be going to Barry. Are we not, Tom?
Yes, that's right. Barry, are you with us?
Yes, I am.
Fantastic. Then let me introduce you. Barry Honeysett is an engineer of great earth building experience from Devon, who's supported a couple of the projects here in the UK, and is going to give us an overview of the engineer's experience of building with CobBauge. Over to you, Barry.
Thank you, Tom. Right. So earth wall construction, that's been used throughout the world, throughout the centuries. So we know it works. What we have to do in the modern world, though, is to demonstrate that it is a viable material and that it can support the loads and do that safely. So the main problem with earth walling is that every site will have different material. So each site will need to have the soil tested to find out its strength. So unlike most other materials where it's been manufactured and pre-tested, so you know figures for the material, with cob and earth material generally, you need to take the material that you're going to be using for that site and do the tests. Tests in this instance will be taking the sample and forming a 200 deep times 100 diameter cylinder and drying it to the same sort of moisture content that the building will be subjected to, and doing a load test on it. That will give you a figure for that soil. Preferably you would do several, so that you take the lowest figure for your tests. So once you have that, you then have to adjust it to add some factors of safety. And for that, the methodology that we've adopted is to do something very similar to the masonry codes, where a series of factors of safety are applied for both the material, the work, manufacturing of it, and also adjustments for extra loads that are placed on the material. So, for instance, with the Plymouth project, the samples that we were getting, they were giving us a strength of approximately, just look it up, approximately 1.2 newtons per millimeter square for the samples. That was then adjusted so that by the time the stress that we actually use for the design is about 0.23. So as you can see, there's quite a large factor of safety being applied, something in the region of about 5. Now, with that strength factor, you can then check the load capacity of any section of wall for both the general load that's applied, and also where you have concentrations of load, for instance, underneath beam bearings, lintel bearings, etc. Trying to make sure that you don't end up with a short section of wall carrying large amounts of load wherever possible. The other load that you need to take into account is lateral load. So for instance, wind being blown against the thickness of the wall. So now this material doesn't have any tensile strength, or at least we assume it doesn't. So the only way that it can resist that is through the stress provided by the loads that are coming from above, including its own dead load, counteract any stresses that are created through bending and overturning loads. So that is the type of process that one has to go through in designing the building, and in particular, just checking the concentration of loads. And if you have any very tall, thin walls, then you also have to check it for its slenderness as well, because there is the risk of a thin, tall wall buckling, and extra factors are applied to the strength in those instances. So, as I say, each site is different. You need to take samples, get those tested, and then from those figures, you can do your design calculations. Now, with CobBauge, the wall that is used for the structural element is about half the thickness that you would do for a normal cob wall. So there again, it's more critical that these the loads are checked and the stress levels are not exceeded. Other considerations that you need to take into account is the most likely cause for a failure in a cob wall is if it becomes damp. So detailing the walls to minimize the risk of water getting into the wall is critical. So nice wide overhangs on the roof, making sure that sill and window details don't allow water in, and avoiding having pipes passing through the wall that could leak and then cause a problem later. There is also the need to keep the wall out of the ground. So there's always a plinth at the base, as you've seen from the various details.